Hey everybody. So I am going to try much better on these lecture videos because the ones that I'm taking in class just aren't working well. So I'm going to go ahead and do a special lecture video for you guys. And so I hope it comes out a little bit better than the first couple. So today we are going to start on talking about functions and what they are and how we use them in C. So it's going to be kind of an introduction to functions. So we're going to talk about that. We're going to talk about the midterm. So everything that you need to know for the midterm will be completed as soon as we get done with today's lecture. Okay. Midterm will be Monday in class. Bring a pencil and paper. If you are an online student, you will be using Proctor Free and you will have 90 minutes to complete. So please make sure that you adhere to those things. The only thing that I am allowing students to bring is the quick reference card that was distributed in class, and the attachment is in e-learning. But other than that, no notes or anything like that. It shouldn't be too bad. So let's start with our functions. So most computer programs are made for a reason. We're made to solve real world problems. And remember, we've talked about this in class. The problems that you're going to solve when you're programming are much, much larger than what we're doing in class. In class, we are doing very controlled group of examples in order to practice certain things. So, what we're doing, not really real world, but we're getting there. So in order to do these larger programs, you're going to want to break them up into much smaller pieces, each going to do a distinctive step, usually one or two, not more than that. But it's going to be much more manageable to figure out what's wrong or to debug or test if you break up the much larger problem into smaller. We're going to call this divide and conquer. So that is going to give us a way of taking that big chunk of a program, right? And we're going to complete it piece by piece, right? There's an old English saying that says, how do you eat an elephant? Well, you eat him bite by bite. Okay, so that's basically what we're doing. So today we're going to describe some key C features for designing, implementing, operating, and maintaining large programs. In order to do what we call modularization, and that is making smaller modules to make that large program much easier to implement. So we're going to use what we call a function, and that's going to allow us to modularize the program by combining some of the functions that we write along with the standard library. We talked about standard library day one, and we haven't really come back to that. We're going to get a little bit more into standard library as we go on. Okay, the C standard library has a bunch of different things that we can use, so we don't have to redo something that's already been done. And it is prepackaged. It's going to make your job easier. You're just going to use something that someone's already been tested and shown to work. Okay. So here, avoid reinventing the wheel. We talked about that, I think, on day one too. And we don't want to do something that someone's already done. Okay. Might as well just use what's already been done. So if you look at this picture here, you might have a main program and it might use these three functions, right? And there's nothing to say that that function can't call another function. Okay, we're going to be able to nest these just like we nest the control loops that we have. So in order to modularize, we have to do a few things. So number one, we have to define, okay? And I feel like we do this define function in just about everything that we do, okay? We define the variables, we define the scope and things like that. So it's written once and you never have to see it again, okay? Number two, we've got the calling and the returning functions. Okay, these are some vocabulary words that we're going to see. So a function is called or used, or we use the word invoked. Okay, a common analogy is like your boss will ask the user. You've got this kind of hierarchical management system. Okay, so the boss is the caller, asks the worker to do something. it's the function call, okay? So you're asked by the caller, the called function does something, okay? And then you report back when it's done. So either you report back it went fine, or you report back, hey, we had an issue, okay? So the boss function does not know how the worker performs. Boss function doesn't care how the worker performs. It says, go do something. So the function just goes and does it and reports back. Either I have a report and you wanted an answer, or it returns successfully, okay? You can also call other functions. You never need to know. One of the most important that we have, and I mean, I come from an analytical background, so for me, it was the most important, is your math, okay? Math is math. We never have to duplicate it, okay? So there is a header, math.h. Okay, if we're going to use this, then we do that hashtag include, and then we put math.h. That's not too bad. That doesn't look too bad. Okay, so we've got that math.h in the, so if we were to use any of these, we need to put that at the very top of our program, okay? So it calls, I mean, the math function's got hundreds of different things to do. Basically, it's got every function that's on a scientific calculator. So here, let's say we want to do the square root of a number, okay? So for example, here we've got 900. So I can say, call my square root function right here, and I'm going to pass it the number I want the square root of, okay? So this right here calls the square root function to calculate the square root of 900, okay? Then it's going to print the result, okay? So your square root takes a double and it returns a double, okay? So it's going to give a number, it's going to take a number and then give you the number, the square root of it back, okay? All of the functions in the math library that return float type values are going to use a double. Remember, there are several different variable types that use decimals, but the math function library, everything's going to be a double. Here are some just quick examples of ones that you might know off the top of your head, okay? So the first one, we've got square root, the square root of x, cube root, CBRT for cube root. We've got exponential functions, so e to the, right? We've got a logarithmic, we've got a log base 10. And then we've got the absolute value down here. We have f abs, okay? So the absolute value of a floating point, which is the f part of that, okay? So your f abs of negative 13.5 would be positive 13.5. There are so many other functions, though, to call in the math library. So if you're ever looking for something to do that you would normally find on a scientific calculator, check out the math library functions. So functions in general, main is often considered a function that performs the majority of your program's work. Remember, main is where you go to start any program. Every program has to have a main, and that is where it starts, okay? So why do we want to create this modularity and this functions, okay? Well, the divide and conquer, we already kind of talked about that. It makes program development more manageable because you can test in smaller chunks, you can debug in smaller chunks. But the other reason is the software reusability. Okay, oh, that was a terrible line. There we go. My software reusability. So we can create a function and use it as many times as we want. So we can create a function from, say, lab 1 and use it in lab 2, 3, 4, 5, 6, right? There's no limit to the number of times you use that function. With good function naming and definition, you can create programs from your standard functions that accomplish specific tasks that you like, rather than having to do custom code, okay? The big word here, abstraction, okay? That's a word that you're gonna have to know the definition of. So an abstraction means, I don't care how you do, I don't want the details, just get it done, okay? So basically you're hiding the details from the user when it comes to performing any tasks within that function, okay? Each function should be limited to a single well-defined task, or maybe possibly 2 tasks. But you remember, you want these very, very small. If your function is getting too large, it means you're going to need multiple functions. Okay, so best to break a huge function into smaller functions, and we call that decomposition. Okay, so your bigger function is way too large, you're going to have to cut it down. Each program that we have had, we've used main, and main is a function definition. Okay, but how are we going to write our own function definition? If we talked about using the standard library, that's fine. We use that hashtag include in order to bring them in. But how do we look at programs that we want to write our own functions for? Okay, so this is going to be a function. We're going to call it square. And square is going to calculate and print the square of a number. Okay, so we're talking like x squared. Ooh, that 2 didn't come out. There we go. X squared. Okay, and we're going to do it from 1 to 10. Okay, so here, important things, line 5 right here. That is your function prototype. That is very, very important, okay? So in order to be able to use a function, you have to tell the compiler like, hey, I've got this function coming up, and here are the main points of that function, okay? Now the actual definition of the function is going to be down here. Okay, so 19, 20, and 21, and then on to 22. That's actually where the function is going to be actually coded, and that is considered the definition. Let's see if I can write that on here and not make a mess. Definition. There we go. That's not too bad. Okay, so we've got the prototype on 5. We've got the definition here on basically 20 through 22. 19 is just a comment. Few things to notice. After our function prototype, we do have a semicolon. Okay, so we do want the semicolon there after that to say end of line. Now our main here, we're not doing anything crazy. We've got a loop that loops through 10 times and it calls that square. Okay. Few things to notice. We've got a return value, and we've got over here parameters or arguments. Okay. So the first one, the return value, that is saying after I perform this function, I'm going to give you an int back. Okay. These in here mean I'm going to send you an int in order to do what you need to do. Now, when I look back up in the main, line 14 here, that is the caller, and it is invoking or calling the function on line 20. Okay, so when it gets to the portion where it says square, it comes down to find where that is. It's going to return another keyword, a value, and the value is going to be returned back to where it was called from. Okay, so line 14, it invokes or calls square. The performance is done down on 2021, and then the results are sent back up to 14. Now, what this receives down here, when it talks, it's a copy of the parameters. Okay, so if I make a change in here, down here of it, it does not change it up here. Okay, it makes a full copy of it. The other thing is that these parameters are local. Let's see if I can put that here. Local, which means they only exist in this function. Anything outside of those curly brackets of that function knows nothing about what goes on inside that function. Okay, so for each function, we've got to do 3 things. 1, we do the prototype. That's not really coming out very well, is it? Prototype number 2, we have to call it. And then 3, we have to define it. That's not too bad. The word prototype didn't come out well, though. Prototype. How's that? Okay, so those are three things that we have to do. And when we look at those three things, so when we talk about that, okay, number one is line 5, number 2 is line 14, and number 3 is the group down here, okay? When we look at those three things, it has to agree in the number of arguments, the argument types, the argument order, and the return type. So you've got 4 things that it has to have the same. Okay, so the number of arguments, there's 1 here, 1 here, and 1 here. Okay, so we're good. Let's change color. Okay, number 2, the argument type. I've got an int, x is an int, and it says int. So we're good to go. Argument order, there's only 1, so there is no order. So that one's a check. And then the return type. So we've got int, it wants an int, and it's returning an int. Okay. So the prototype, the call, and the definition, those 3 have to agree in the number of arguments, the argument types, the argument order, and then finally the return type. Now, if I was going to run this, and I apologize for writing all over it, it's going to run something like this, right? So 1 is the square of 1, 4 is the square of 2, 9 is the square of 3, and etc., going all the way up to 10. Now, the function prototype is what is going, I just talked about that. Should all agree in the number, type, and order of the arguments and parameters, okay? And the function prototype and the header must have the same return type, okay? So choose meaningful names when it comes to parameter names, and that's going to make it more readable. Now, what you call it in the, where you call it and what you call it in the definition doesn't have to be the same, okay? And remember, a function requiring too many parameters might be doing too many things, and so you might have to break that up actually into smaller functions. Your return type, parameter list, and the name and all of that should fit on 1 line at most. Okay, so that's probably a good rule of thumb, 1 line. Okay, so we've got a few different things going on, right? In order to just do a generic, we've got a return type right here, right? That's the very first thing that you see. Then we give it a name and we send it the parameter list, okay? Then we have our curly brackets, and that's where we put our block of code. Okay, so your function name is going to be any valid identifier. Typically, we start with a lowercase. We may do something like an action and then a noun that we're doing something to. So it may say square number, or it might say get integer, or something to that effect. But we want to make sure that it actually is reflective of what we're doing. The return type value is a type of the result of the call. We use void to say that we're not going to return. And that's what we use with the main, right? We say void main. That's why our mains have not been returning anything. The return value type, function name, and parameter list are what we call the header. Okay, so it's like the first line of what is over there. So this right here is what we call the header. I'm still in green. Cool. The parameter list can be comma separated. So if you have none, you could put void, and each parameter must include its type. So if you have multiple, you can say int x, comma, int y, comma, int z. Okay. So if I wanted to send it 3 different variables. Okay. If you put a semicolon after it, like here, that's going to give you an error. Okay, so it's just like what we did with main, no semicolon after the header and between the curly brackets. The statements in those curly brackets, that's our function body, or which is also going to be a block. We've talked about that block of code. Any variable put and declared within a block is only known by that block. Okay. Outside of that block, no one knows it exists. Now, the other thing you cannot do is you cannot put a function within a function. Each function has to stand alone on its own. You can call or invoke a function within a function, but you cannot define a function within a function. Returning control from a function. So there are three different ways that we can return control. Okay. The first way is to end. Okay. So if you get to the end of it, control is simply returned. Whether you find the curly bracket or if you have a return. And you can do a return with a semicolon with no with no values in it. The second way is that if the function does return a result, the following statement returns the expression's value. So this one has a return expression. So return X, okay, or return 4, okay. The third way is you can do a break. But that's really not how we want to do it. So let's stick with our returns. So let's take a look at another section of code. We're going to consider a function called maximum. Okay, so we're going to want to create a function called maximum that returns the largest of 3 integers. Okay, maximum returns its result to the main with a return statement and then prints the value returned. So you're going to give it 3 different integers and you want to return the maximum of those 3. So let's take a look at this code. Here we can see some things already, right? We've got our function prototype. We've got our call is right here. And then we have our definition. So we've got our 3 steps. Let's see if it does our agreement test, okay? So we've got 3 arguments here. Oh, that didn't even draw it. We've got 3 arguments here. We're sending it 3 here, and it's expecting 3. So we pass that test as well. The argument types, we've got int, int, int. Number 1, number 2, number 3. We've got int, int, and int. And then here we've got int, int, int. So the argument types match. The order, so we've got X first, Y, and then Z. We've got X, Y, and Z, X, Y, and Z. Here, it doesn't really matter the order of them once we get them in the function. We just need to be able to recognize that they have 3 separate values. And finally, the return type. It wants an integer. We're printing an integer, and it's going to say it's an integer. So we have passed all of those tests that we have of matching the prototype, the call, and the definition in our 4 different categories. Here in our main, we do our invoke here down on 17 when it calls maximum of 3 numbers, number 1, 2, and 3. Now, if we look down in our function is going to be 20 to 31 over here. Okay, so that's the end of main. Ooh, that you can't see that at all, huh? It says end main, trust me. So here in my function, it's gonna go through all 3 of those variables and define and figure out which one is the largest. Okay, and it is going to return the max. Now, something that you should know. So here, I define this int max on line 22. Max is only then known from line 23 and down when it comes back up to 17, because this return, right, it's going to send it back up to 17. It does not know max. Okay. Max only lives within its own block. Okay. So just remember, when you define a variable, it only lives within the block. The same thing goes with our main. Okay. That was supposed to be a curly bracket, which didn't happen. That's fine. I've got 3 variables declared here on 8, 9, and 10. And those 3 variables, number 1, number 2, number 3, only live between 7 and 18. Okay, outside of that, they don't exist. Okay, so that's just something to point out. So now if I put in values such as, let's see, 22, 85, and 17, okay, what's going to happen? So you're going to come down to your function when you get to 17, okay, and you're going to say int max equals x. So your max, max equals 22, okay? If y, which is 85, is bigger than max, which it is, so then max then is given the value of y. That's an 8 and a 5, I promise. Okay? If z is 17 greater than 85, no. So then my max is equal to 85, and it will print 85. Okay? So it just does that little kind of organization of 3 numbers. Now, when we talk about headers, that is going to be that .h that you have. Okay, so we're going back to the standard library information. Okay, so each standard library has a corresponding header containing the function prototypes for all the functions in that library, definitions, all the good stuff. And I'm going to show a table here, which is going to give a few of the ones that we have either used before or that kind of are popular to use. Okay, you can create a custom header, and you put them in quotes rather than in angle brackets. So if you decide that you have a bunch of functions that you want to use over and over again, you can actually create your own header file so that you would have a hashtag include at the end of any program where you actually want to use those functions. Okay. So last, we're just going to take a look at some of these common headers. So float, we've got some great information about floating point size limits. There's that math that we talked about, that math.h. Oop, my pencil ran out. That math.h that we had talked about. And then there's that stdio. Okay. There is a standard library. There's also a string that we're going to be using. And there is one that's actually a time.h, which can be useful if you need to get a date and a time, and if you need to start adding hours or adding days. And when if you hop over months, it's kind of already predetermined to do that. So I am going to put a link in our e-learning, if I can get e-learning working, to where you can see some of the information that is within these headers. We're going to talk more about it after the midterm. But for right now, that's all you really need to know about functions. So we talked about functions today, really just an introduction and how we use them, why we use them, and kind of the formatting of them, right? We have the 3 different types to use. We've got the prototype, the call definition. You need those 3 parts to work together, and they all need to agree in the number of arguments, the type of argument, the order, and then your return type. Okay, so that's really a lot of what we are discussing today. In midterm information, we are done with the info that you need in order to start studying for your midterm. Okay, midterm will be on Monday. If you're in class, bring a pencil and paper. I've got it on paper. If you want to do it on your PC, that's fine, but you will have to use Proctor Free. Just a warning. Coming up for the rest of this week and into next week, Lab 4 and Homework 3 are related, so do Homework 3 first. Homework 3 is going to be the flowchart for Lab 4. So please do that before you come into Lab in order to make the best use of your time. Okay, Homework 4, it was a handout that I gave in class on Monday. It is attached in e-learning. It is a crossword puzzle. It's to try to get you thinking about some of those definitions that we've been talking about to kind of prep you for midterm. Okay, so you can either hand it to me in person Wednesday, Thursday morning, you can put it under my door if you're on campus. But just try to, if you want to give it to me in person, make sure I have it before Thursday, probably about noon-ish, okay? Otherwise, you will have to submit it through e-learning. If you want to do it that way, you can just type out 1 through whatever, however many definitions there are, and just type out the words. You don't have to use a crossword puzzle portion of it. I just thought to try to make it a little fun. And to wrap up, midterm exams starting promptly at 8 o'clock. So hopefully if you are in class, you come as early as you can. Otherwise, you will have to use Proctor Free, which everybody loves, and we all have our issues with. So please let me know in Discord if you have any questions, and I will see you all later.